These are the newest images of 3I Atlas, captured just yesterday. And if I'm being completely honest with you, this might be the most shocking and confusing anomaly we've ever recorded from this object. For months, astronomers have been building one narrative, that 3I Atlas was on the verge of breaking apart, slowly crumbling from the inside, behaving exactly like every other unstable comet we've observed in the past. Every piece of data pointed to one conclusion: this thing should be dying. So when these fresh images first appeared, everyone expected to finally see the inevitable multiple fragments, debris clouds, maybe even the start of a full breakup. But instead, what we found was something far stranger, something that completely overturns what scientists were so sure about. 3I Atlas wasn't just doing something weird, it was defying the most basic rules we use to understand comets. In this video, I'm going to walk you through everything we know so far, why experts were certain it had to be fragmenting, why the earlier data seemed impossible for a solid object to survive, and how these newest images have forced astronomers to rethink everything they assumed about this ancient visitor. Because whatever is happening with 3I Atlas right now, it's not just unusual, it's rewriting the entire story. To understand why these new images shocked astronomers so deeply, we need to go back to the data that convinced everyone that 3I Atlas had to be fragmenting. Not maybe, not possibly, but inevitably. On November 9th, telescopes captured something no one expected: a massive tail stretching millions of kilometers. With a second tail pointing toward the sun, that is extremely unusual. Tails don't normally point toward the star that heats them, and here's where things get strange. Comet gas doesn't blast out fast. It only escapes at around 1,500 kilometers per hour, which for space is actually pretty slow. So for 3I Atlas to suddenly develop tails millions of kilometers long, that would require constant, intense outgassing for months. But just days before these images, there was nothing. No tail, no jet, no indication that anything was happening. It's like a silent volcano suddenly erupting with no warning. Then came the size. Problem: the math showed that for Atlas to produce tails this massive, it would need 1,600 square kilometers of active surface absorbing sunlight. That's the same as a sphere, nearly 23 kilometers wide. But Hubble has already measured 3AI Atlas at just 5.6 kilometers across, so its surface area was 4 times too small to produce what we were seeing already. That made no sense. But the numbers got even more disturbing. When scientists calculated how much material those enormous tails must be carrying away, they reached a nearly impossible conclusion. 3I Atlas was losing 50 billion tons of material every month, but the object itself weighs only around 33 billion tons. In other words, the comet should be losing more mass than it actually has. That is physically impossible unless the object is breaking apart into piece sand. Each new piece is adding its own fresh surface area for sunlight to blast more gas outward, and this wouldn't even be new. We've seen this exact behavior before. In 1992, the comet Shoemaker-Levy 9 broke into 21 fragments, and the total amount of material it released suddenly made sense because each piece contributed to the OUTGASS. So by November 9th, the conclusion seemed obvious. The 7 massive jets, the multi-million kilometer tails, the impossible mass loss calculations, everything pointed to one scenario. 3. Atlas had to be fragmenting. There was simply no way a single intact object could survive those stresses, or at least that's what everyone believed. And then everything flipped. On November 11th, just 2 days after those massive chaotic tail images, 2 legendary astronomers, David Jewett and Jane Loeb, the same duo who helped rewrite our understanding of the outer solar system, pointed one of the Canary Islands' powerful telescopes directly at 3I Atlas. Everyone expected confirmation of the fragmentation theory pieces, debris trails, drifting through space. Instead, their published report came with one shocking title: 3I Atlas, still single, not split, not shattered, not dissolving into a cloud of pieces, still one single, solid object. And the images they released, they didn't just casually look at the comet and shrug. They performed a deep, methodical, high-precision forensic analysis of everything around Atlas. Here's what they found. 3 Atlas was sitting roughly 1.5 astronomical units from the sun. That's around 214 million kilometers and more than 320 million km from Earth. They studied a surrounding region over 500,000 kilometers wide, a massive bubble of space where any fragments, even tiny ones, would have revealed themselves. Inside that enormous field, they detected just one thing: a single, bright nucleus, the core of the comet, unbroken, undisturbed, holding together against all expectations. Surrounding, it was a glowing coma, a huge cloud of dust and gas, but even that wasn't simple. It had complex structures, strange patterns, and multiple layers, the kind of chaotic shape you'd expect from something undergoing extreme stress. And then came the tails they found too, just as earlier images suggested, but now the details made everything even stranger. One of the tails was pointing almost directly toward the sun. The angle was measured at 1/6, while the sun's true direction was at 115, only a difference of 9 degrees. That's called an anti-tail, a tail that appears to stretch toward the sun, a rare optical effect caused by dust particles aligned in a specific way. The second tail was pointing in the normal direction, away from the sun, measured at 301, but the real shock wasn't the tails. It was the absence of something. Using different imaging techniques, brightness, stretching, contour mapping, false coloring, radial intensity analysis, they searched for even the smallest hints of fragmentation, and they found none. Not a single piece, not a single trail, not even a faint signature of debris. Separating if 3i Atlas had broken into even 16 pieces, much less the dozens required to explain the mass loss numbers, those fragments would have been drifting apart, detectable through any of these methods. Yet every method told the same story. 3i Atlas is still one object, completely intact, still holding together after the most violent part of its journey, its closest pass by the sun on October 29th. This is the moment everything changed, because now scientists are forced to confront an uncomfortable truth. This object is not behaving like a normal comet. It's producing insane amounts of gas. It's generating massive tails. It's showing jets so powerful that the math says it should be tearing itself apart, and yet it isn't. Something doesn't add up. This is the moment where the story moves from it's probably just a weird comet to we might be looking at a category of object we've never seen before. Here's the part that has every astronomer scratching their head. 3i Atlas just survived something that should have absolutely destroyed it. Let's be clear, this object didn't just cruise past the sun like any regular comet. It endured the most intense phase of its entire journey, a region of space where most comets either fracture, collapse, or explode from internal stress. On October 29th, 3i Atlas hit perihelion, its closest point to the sun, and at that distance, the heat wasn't just warm, it was enough to boil ice instantly, rip gas out with violent force, and create internal pressure strong enough to tear a normal comet to pieces. And yet, 2 weeks after that brutal encounter, what do we see? Not debris, not a cloud of fragments, not a shredded object limping away from the sun. We see one solid nucleus, still blasting out jets from multiple directions, still generating enormous tails, still accelerating in ways we can't fully explain. This is where the mystery deepens. Why should it have broken apart? Because the physics say so. To create the tails we're observing, 3i Atlas would have had to lose billions of tons of material, enough to physically hollow it out. The pressure from this outflow, the jets, the heat, the gas violently escaping should have cracked the nucleus like glass. This isn't speculation. We've seen it before. When Shoemaker Levy 9 passed by Jupiter in 1992, the tidal forces ripped it into 21 pieces, and the increased surface area made it lose even more mass. This behavior made sense. But with 3i Atlas, the data tells us it's losing more mass per month than the entire comet is believed to weigh. That's physically impossible, unless it's already shattered into many pieces with tons of new surface area exposed, but it hasn't shattered. And that's the part no one can explain. So how did it survive? Here's the baffling conclusion. If 3i Atlas is truly a natural object, then its internal structure and surface chemistry must be unlike any comet we've studied in the solar system. It is enduring thermal stress that should internally fracture it. It is generating jets strong enough to blow a normal comet apart. And it is surviving mass loss levels that would instantly destabilize anything made of ice and dust. Yet, 3i Atlas is still one piece. Still active, still accelerating, still holding itself together against everything physics predicts. This is the point where scientists start to admit quietly, reluctantly, that maybe the models we use for normal comet simply don't apply here, because nothing about this object is normal. Theory 1, a 10 billion-year-old cosmic ray crust. 3i Atlas might be older than our solar system itself, maybe 7 to 10 billion years old. Over billions of years, cosmic rays would have blasted its surface, changing the chemistry and building up a strange crust. The JWST has already found evidence supporting this. 3i Atlas has 8 more CO than normal comets. Cosmic rays may have converted carbon monoxide into carbon dioxide and created a hardened, weird outer layer that sublimates in bizarre ways. This crust might hide channels and pockets that give the comet more effective surface area than we can see. Theory 2. The mass calculations might be wrong. We might be overestimating how much material the jets are releasing. Maybe the tails look bigger than they actually are. Maybe they're extremely good at scattering sunlight, making them appear more massive. If the true mass loss is 5 billion tons per month instead of 50, the numbers suddenly make sense. But there's a problem. Scientists have been calculating comet mass loss this way for decades, and the method works. So if it's suddenly wrong for 3I Atlas, we need to know why. This object is not behaving like a typical comet. It's not following the rules. And every new image raises more questions than it answers. If you watched until the end, drop a like and subscribe for more updates on 3I Atlas and everything happening in our universe.